geospatial data, essentially collecting data of the real world and turning it into something that people can use digitally or on the table, basically.
It's a laser scanner, so you will accurately measure the topography. So as you can see here is a complete product of what we have scanned.
So what we want to do is to take this very, very high level, all the work that we do, laser scanning or aerial mapping, and bring it to the greater audience.
In a world where accurate and comprehensive geospatial data is crucial for urban planning, environmental conservation, and infrastructure development, the need for advanced mapping and surveying techniques has never been more pressing. Traditional methods often fall short in terms of efficiency, precision, and the ability to capture detailed information across varied terrains and structures. This is where innovative solutions come into play, transforming the landscape of data collection and analysis. In this episode, we will learn from Aaron Tan and his Tech Heroes team of UAS mapping on what it takes to deliver next-generation mapping and survey services to the local industry. And it all started with his passion towards drones.
I first came back from overseas. I came back from Melbourne, Australia, to Malaysia to join the family business, which was actually selling surveying instruments. So at that point of time, obviously, I also enjoyed sort of like flying drones and getting into the drone hobby, I guess. And at that point of time, there was a need from our clients as well as our, and now some of my partners, which is in the professional surveying industry, to up-tech, to start using drones to collect geospatial data. Well, geospatial data, in some sense, it's a very, very high-level thing. It's important because we use this data to it informs us of the decisions we can make for our world. And a good example for this is we collect this data so that we can, from very low level, high level, not low level, so that we can do construction. All these things all related to geospatial data, which is essentially collecting data of the real world and turning it into something that people can use digitally or on the table, basically.
Aaron Tan is blessed with a team consisting of various departments, each based on their expertise and experience. Every member plays a crucial role in delivering the best services to their clients.
For US mapping services, we have 5 main services. So the first services we are focusing on aerial LiDAR and photogrammetry data collection. So second, we have underground utility detection. Third, we have 3D virtual tour. Fourth, we have GIS services. And then fifth, we have terrestrial and mobile laser scanning.
To deliver precise and detailed data to their clients across various industries, UAS mapping utilize high-end tools and technologies. The advanced equipment includes state-of-the-art drones for aerial data collection, ground-penetrating radar for underground utility detection, and sophisticated 360-degree cameras for creating immersive 3D virtual tours. Additionally, their GIS services leverage powerful software to analyze and visualize spatial data, while terrestrial and mobile laser scanners capture detailed 3D models of environments.
So as you can see, within the box, you can see that there's few items. So you can see the drone itself, which is the body, and then the controller. So now my colleagues, they will demonstrate how to assemble the drones. Okay. So as you can see, we managed to take out the drone, and then now they will just expand the wing. While they are assembling the drone, I will talk about the payload. So we have 2 types of payloads. We have payload number 1 called P1 and payload number 2 called L1. So P1, the usage of P1, is for photogrammetry usage. So for aerial photogrammetry, photography, we will use this. And for L1, it's a laser scanner. So what it does is like it sends out laser pulse and then collect back laser pulse. So you would accurately measure the topography.
To operate these drones for enterprise usage, remote pilots like Shamirul and Kivaldik must have at least a basic remote pilot certificate of competency (RCOC). In Sarawak, obtaining a drone permit involves navigating through 3 stages with different agencies: the Premier's Office, the Department of Survey and Mapping Malaysia (JUPAM), and finally, the Civil Aviation Authority of Malaysia. Alright, we've seen their gear and we have a licensed pilot ready. Now, let's see them in action. One of their main services is aerial LiDAR and photogrammetry data collection. Topographic surveys provide detailed and accurate maps of the Earth's surface, helping to identify elevation changes, natural features, and man-made structures. This information is essential for making informed decisions and ensuring the success of projects across different industries.
Sekarang ini kita akan menerbangkan drone Matrix 350 daripada DJI bersama dengan payload DJI L1. Jadi hari ini kita akan menggunakan LiDAR mapping, iaitu berfungsi untuk mendapatkan kontur dan spot height di sesuatu kawasan. Ini berguna untuk lebih kepada engineering dan survey department. Okey, bersama kita punya pilot Kendrick akan menerbangkan drone kita pada sekarang ini. Take off. Okey, sekarang kita akan terbang setinggi 30 meter daripada tanah dan kita menggunakan speed 5 meter per second. Satu set bateri boleh terbang bersamaan dengan 20 minit, iaitu lebih kurang 15 hektar untuk satu mission.
The drones fly over the designated area, emitting laser pulses towards the ground. These pulses bounce back to the sensor, recording precise distance measurements. The LiDAR system collects a vast amount of data points, known as a point cloud. Each point in the cloud represents a precise location on the Earth's surface, capturing details like vegetation, buildings, and terrain features. The collected data is transferred to powerful computers where specialized software processes the point cloud. This involves filtering out noise, aligning the data with ground control points, and generating a detailed 3D model of the surveyed area.
So we'll demonstrate how are we going to process the data. So to put it simple, we'll insert the data into this program, and then there's some parameters here. So it's a very, very straightforward process, as long as you know what are the parameters. As you can scroll through here, all these parameters we have already configured. And then the next step, we're just going to click Start Processing. So it will ask you whether the parameter is okay, then we'll just click OK. So once it's running, so it will start to construct the data. So as you can see here, these are called point clouds. So as you zoom in, you can see they are points, okay? So these are represented by the laser. Laser, when it scans, it reflects to the sensor. It collects as points, as you can see. These are called points. So for another services that we have, we are offering is called terrestrial scanning, and then mostly usage is on 3D modeling. So as you can see here, the program that we have is called Cyclone. It's a Leica program. So we're using that to scan a building. So as you can see here is a complete product of what we have scanned. What it does is it accurately capture what the building is. So you can see this is the outside facade. We can see whether there's crack or not. Other than that, we also scan within. So all these are scan points. As you can see, there's red dots here. Those are where our equipment stands. So what it does is it will collect the data within the space. So it will accurately portray what is inside.
Point clouds provide highly accurate and detailed three-dimensional representations of surveyed areas. The term obtained ground in the context of LiDAR and point cloud data processing refers to the process of isolating and identifying ground points within the dataset. Obtaining ground points is crucial for applications that require accurate terrain models such as flood modeling, land development planning, and infrastructure design. In addition to UAV LiDAR mapping, UAS mapping also provides road scanning and profiling services. Their road scanning services offer precise and comprehensive analysis of road surfaces, enabling efficient maintenance planning and infrastructure development.
Okey, di sini kita ada beberapa komponen iaitu laser scanner dan proses data. So, fungsi road scanner ni adalah untuk melihat smoothness dan texture untuk jalan-jalan tar. So, di sini kita ada monitor dan CPU yang akan memproses segala data yang kita collect. Ini adalah komponen yang dipanggil speedometer. Speedometer ini adalah untuk mengukur kelajuan kereta. Di samping itu, kita dapat melihat berapa jarak data yang kita telah ambil dibantu oleh GPS untuk mengetahui koordinat dan lokasi yang tepat dalam kita punya data.
The laser scanner emits laser pulses that reflect off the road, measuring distances and creating a high-resolution point cloud of the surface. The vehicle typically operates at a controlled speed, often around 40 km per hour, to balance data accuracy and operational efficiency. The collected data is then processed to analyze the road's profile, including identifying defects and assessing overall condition, which aids in maintenance planning and infrastructure development. The combination of drones, laser scanners, LiDAR units, and high-resolution cameras also allows UAS mapping to offer 3D virtual tours. To see how 3D scanning is done, Jim offers to demonstrate the process by scanning the war memorial in Kuching.
So you can see here beside me is a laser scanner. So this brand is called Leica. How does it operate? It's very simple. So we just identify the objects that we want to scan, place it, and then by using an app connecting with this equipment, we can undergo the data collection, and then we will transfer the data to the computer to undergo either further analysis. So as you can see, right now if I click start scanning, it will start to spin itself. So as the equipment try to turn, it's collecting two types of data, which is the laser pulse and a photo. So it will turn 360, so every time it will turn 4 times. 1, 2, 3, 4. Once it makes a complete circle, then it will stop, the software will process itself, and then we can have a look at what's the output.
The scanning process is repeated from different points to create a more detailed and accurate representation of the war memorial. The 3D scanning can be used for various purposes, including historical preservation, architectural analysis, virtual tourism, and educational resources. It provides a precise digital record that can be referenced for restoration projects, shared with the public, and used in virtual reality applications. One of the most notable projects assigned to UAS mapping is scanning the Borneo Cultural Museum, the largest in the country and the second largest in Southeast Asia.
Sekarang ni, kita akan buat 3D modeling untuk Borneo Museum Sarawak yang berada di belakang saya ini. Jadi kita buat 3D modeling menggunakan drone untuk mengambil setiap sudut dan aspek detail yang ada dekat museum. Jadi setiap gambar itu akan digabungkan dan dijadikan digital yang boleh dibuat secara 3D. Take off. Sekarang ketinggian tu bergantung dengan apa kita punya projek. Kalau lebih kepada architecture ataupun 3D modeling, lebih baik lebih dekat dengan subjek adalah lebih baik. Tetapi sekarang kita mempunyai kamera yang megapiksel lebih besar, walaupun jauh, detail tetap nampak. So, pasal ketinggian ataupun berapa jauh daripada subjek itu terpulang apa spek dan format yang klien mahu.
By providing a 3D scan of this building, UAS mapping can create a precise digital representation that serves multiple purposes and offers numerous benefits. The 3D scan facilitates detailed architectural analysis, aids in preservation efforts, and supports virtual tours, making the museum accessible to a global audience. Knowing that knowledge and skills are valuable to the industry, UAS Mapping collaborates with educational institutions to organize specialized courses tailored for professionals already working in the industry. One notable workshop offered by UAS Mapping is focused on underground utility detection, where professionals learn to use advanced geospatial technologies to accurately map and analyze subsurface infrastructure.
We worked with Sarawak Skills to come up with certain programs. So the latest program that we have is targeted to audience for underground utility detection. So if you see, there's a lot of nowadays there's a lot of constructions going on. So there's a lot of cables underground. So we wouldn't know what's underground unless we have certain like as-built drawings, this kind of thing. So to prevent doing excavation, to prevent damaging of pipes, water pipes, telecommunication lines, and electrical cables, that's where this underground utility detection comes in.
The technology can be categorized into three main types. One is the electromagnetic locator, EML, also known as a cable and pipe locator, which operates based on electromagnetic field principles. This technology allows contractors to locate various underground metallic utilities. When encountering non-metallic utilities, the same technology can be enhanced with suitable accessories to locate them, provided there is an access point.
But we also know that some of the utility, which is pressurized, and for example, gas pipes and water pipes, where you cannot or the operator cannot insert anything into the pipe to allow them to trace. There is where GPR technology, ground penetration radar, is introduced into the utility industry that allow the operator without excavation, and they can just scan through the surface and to locate the position of the pipe and to mark, to gather the depth and mark the spot where the pipe located.
Workshop participants are also given the chance to try the equipment hands-on. This allows them to gain practical experience, understand the intricacies of the technology, and build confidence in using these advanced tools for locating underground utilities.
Tujuan kami datang sini untuk mengambil pengetahuan pasal how to pakai utility ataupun teknologi yang terkini ini supaya dia boleh menolong bila kami membuat kerja pengorekan di tepi jalan supaya tidak salah cangkul ataupun wrongly excavate the utility others parties agency supaya tidak menimbulkan kerja breakdown macam water pipe burst, power failure.
So there is the two different type of training that we provide. Those that is upskilling and reskilling, where you get a certificate of completion, where you come out and then you learn the new skills and be able to use it in your workplace. And then there is the other one that is a competency training, where you come out and then you get, if you pass the exam, you get a license to practice as a pipe fitter, as a manslayer, as a wireman, as a chargeman, and so on.
By sharing their knowledge and expertise, UAS Mapping demonstrates a commitment to elevating the industry. In the future, they aim to target a larger clientele and bring their educational programs to the highest level possible, ensuring that more professionals and organizations benefit from their cutting-edge insights and contribute to the advancement of geospatial science and technology.
Our current vision, obviously, is to, in some sense, democratize geospatial data. A lot of what we do is locked behind closed doors and offices. A lot of times, and I can say an example of this, is a lot of times geospatial data, for example with manned aircraft, is very expensive. It's very hard for a lot of people to even know about it or engage in it. So what we want to do is to take this very, very high level, all the work that we do, laser scanning or aerial mapping, and bring it to the greater audience. And that's our vision, whether it's through data as a service on a platform, or whether it's through databases, whether it's through more interesting service delivery models. We're always exploring these ideas.
Congratulations to our heroes on their incredible journey and the impactful work they do in the geospatial industry. Sarawak has high hopes for their continued success as they push the boundaries of technology and innovation. Stay tuned for our next episode, where we'll explore a groundbreaking technology that has the potential to transform the way people analyze black pepper quality.